Everyone, welcome to your physics class of class 6th. I hope you all be fine. Students, today in this video, we will revise lesson number 1. Okay, in our previous video, we have already completed lesson number 3rd and all the answers of lesson number 3rd. So now today we will revise lesson number 1. Okay, so let's begin our class. So lesson number 1 is matter. Okay, so we will see what is matter. Matter is defined as anything which occupies space and has mass. It can be perceived by our senses, that is smell, touch, sight, hearing and taste. These are the examples of matter. Air, it has mass, it occupies space. Water, hydrogen, all these are examples of matter. Oxygen, sugar, sand, alcohol, milk, all these are examples of matter. Okay, because all of them occupy space and have mass. Things like food, clothes, table, chair, all these are examples of matter. Okay, now we will see the composition of matter. Ancient Indian philosopher considered that all kinds of matter is made up of 5 elements that are known as Panch Tattva, that is sky, air, fire, water and earth. These are called Panch Tattvas. But later, Maharishi Kannad, an Indian philosopher, was perhaps the first to suggest that all forms of matter are composed of very small particles that are known as anus, and that each anu is made up of still smaller particles that is known as parmanu. Now, Greek thinker Democritus called the simplest particle parmanu as atom. Matter is composed of tiny particles known as atoms. However, the number of particles in a matter can vary. Matter can be very large. Means a small drop of water contains 10 raised to the power 21 particles of matter in it. Okay, so these are very small in size. Now later, John Dalton, an English chemist, experimentally found that matter is made up of molecules, and these molecules is made up of one or more than one atom of the same kind or of the different kind. Means molecules are made up of atoms of same kind or of different kind. And matter can exist free in nature, whereas an atom cannot exist free in nature. It simply means that the molecule is the simplest and the smallest particle of substance that is capable of independent existence. Now we will see the characteristics of particles of matter. There are four characteristics of the particles of matter that are called molecules. First one is they are very small in size. Second, they have spaces between them. Third, they are in constant random motion. And fourth is they always attract each other. Okay. Now we will discuss the states of matter. There are 3 physical states of matter: solid, liquid and gas. For example, steel is a solid, oil is a liquid and oxygen is a gas, while air is a mixture of gases. Water can exist in all the 3 states, that is ice in solid state, water liquid state and steam gaseous state. Now we will discuss these properties, distinction between solid, liquid and gases. Okay, we will just discuss in a brief the properties of solid, liquid and gases. How do they differ? A solid has a definite shape and definite size, whereas liquid has definite volume but no definite shape, and gases has neither definite volume nor definite shape. Okay, solids have definite shape because of the intermolecular force of attraction between them is very strong as compared to liquid and as compared to gases. Second, the molecules in a solid are closely packed because of the intermolecular force of attraction. Molecules in a solid are very closely packed because the intermolecular force of attraction is very strong in case of solid, but in case of liquids, the molecules in a liquid are loosely packed. The intermolecular force of attraction between the molecules of liquids is not as strong as in case of solid, and it is weakest in case of a gas. Therefore, the molecules in a gas are wide apart. Now third is the molecules in a solid are fixed at their position. They cannot vibrate. They can only vibrate about their mean position. Means they cannot move from their position. They are fixed at their position. They can only vibrate on their mean position. The molecules in a liquid can move within the boundary of a liquid, but the molecules of in a liquid can move within the boundary of the liquid. Means there are spaces between the molecules of a liquid, therefore they are free to move within the boundary. But in case of gases, the intermolecular force is very weak, and therefore the molecules of a gas can move freely in space. Here the intermolecular force is strong, and because of that the space between the molecules is very less, or we can say negligible, and therefore they cannot move. They do not have a space to move up from their they are fixed at their mean position, and they can only vibrate. But in case of liquid, the molecules can move within the boundary, and in case of gases, the molecules of a gas can move freely in space. Fourth is, the intermolecular forces are very strong in case of solid, but in case of liquid, the intermolecular forces are less strong, and the intermolecular forces are weak in case of gases. Fifth is, the molecules in a solid are closely packed, therefore solids are highly rigid. The molecules in a liquid are less closely packed, therefore liquids are less rigid, and the molecules in a gas are least closely packed, therefore the gases are non-rigid. Okay, these are the different properties of solid, liquid, and gases. Okay. On page number 9, this table is given to you, distinguishing properties of solid, liquid, and gases. You have to read all these properties, okay, of solid, liquid, and gases: mass, shape, volume, compressibility, fluidity, rigidity, diffusion, number of free surfaces, how many free surfaces are there in case of solid, liquid, and gases, packing of molecules, how they are packed. In solids, the molecules are very closely packed, in liquid less closely packed, and in gases least closely packed. Force of attraction, intermolecular force is the strongest in case of solid, slightly weaker than in solids in case of liquid, and negligible in case of gases. Expansion on heating. Solids expand very low on heating, and liquids more than solids, and gases more than liquids. Motion of constituent molecules, they can only vibrate on their mean position. They can move in the direction of in all directions, but within the boundary of the liquid, and they can randomly move in the space that is available to them. Now pressure only at the base downwards, means solids exert pressure only on the base, that is in the downward direction. At all the points in all direction inside the liquids, that is on the walls of the container, means liquid exert pressure on the walls of the container, and they exert pressure on the walls of the container. Gases also exert pressure on the walls of the container, and liquid also exert pressure at all points in all the direction in which they are kept. Okay, where they are kept, they exert pressure in all the direction. Now viscosity, no viscosity, more viscous and less viscous. Surface tension, no in case of solid, and due to cohesive force tends to occupy minimum surface area, and here in gases no surface tension. Okay, now changes in state of matter. The change in state of matter of a substance from solid to liquid or from liquid to gas is brought about by imparting heat energy to it at a constant temperature. Means change in state of a substance either from solid to liquid or from liquid to gas is only be done by imparting heat to the is brought about by imparting heat to it at a constant temperature, from solid to liquid also, and from liquid to gas also. Whenever the change in state occurs, it is it is brought about by imparting heat energy to it at a constant temperature. First case is when we change from a solid state to a liquid state. The process of change of a substance from a solid state into its liquid state on absorption of heat at a particular temperature is called melting point, and is called melting or fusion. Means that temperature, that particular temperature on which a solid changes into liquid, that is known as melting point, and that process is known as melting or fusion when a solid changes into liquid. The heat energy absorbed by the substance increases the amplitude of vibrations of the molecules of the solid, and a stage is reached at the melting point when the molecules acquire sufficient energy to overcome the force of attraction between the particles and they become free to move. The solid thus changes into liquid. Okay, and second is when change occurs from liquid state to gaseous state. In this, the process of change of a substance from this liquid state to its gaseous state at a particular temperature, and that temperature is called boiling point. And the process of this change from liquid state to gaseous state at that particular temperature that we called as boiling point is boiling or vaporization, means that process is known as boiling or vaporization when a liquid on absorption of heat changes to gas. The heat energy absorbed by the substance in liquid state increases the energy of its molecule, and due to which they begin to move randomly and liquid changes into gas, as in case of solid to liquid. In that also the molecules absorbs heat, and because of that heat the energy increases and therefore they becomes free to move and solid changes into liquid. The same way liquid changes into gas on absorption of heat. Okay, so this is your lesson number 1. You have to prepare for your exams. Okay, so this is all for today. Thank you.